Live from the Icebox Studio in Montgomeryville, Pennsylvania. It's the Bill and Corey Show. I'm Bill.
And I'm Corey.
Yeah, welcome back to another episode. Some of the topics we're going to cover today is we're going to talk about mass flow, and then we're going to talk about some broken pressure gauges. And then we'll talk about regulator flow curves.
Oh,
and we're
exciting stuff.
We're going to end up talking about VOC gases and regulators for that. So
viable organic compounds.
Oh, jeez.
Did I ruin the surprise?
Did you ruin it? So, and we got a little history lesson in there too. And we do have the live chat feature enabled in our YouTube show. So you can, you have think of any questions, just go ahead and type it, and hopefully we'll get to them. So we're going to start out, first question for Corey. Can you please provide us with a quotation for 2 mass flow meters with the following specification? They want it for methane, low pressure, about 30 psi, and they're looking for a flow rate of 700 to 1500 cc's a minute. And they want to have data logging capabilities, cables, and software included.
Yes, which that would be the data logging capability. So these are this is our mass flow meter. It only meters the gas, meaning it measures the gas. This is which is our 819 model. This is our model 829 mass flow controller, which, as the name suggests, this one can actually control the flow, and this right here is the valve, and you can tell the difference just by looking at them. So the customer wants this one, and we have an outlet right here. It is an outlet connection that we sell cable for, so you can connect to your computer. This will also, you can power it up, and you can control it from here as well. There are helpful videos on our online store narrated by yours truly showing you how to use this interface, and also the flow software that comes with it, which you can put on your computer, which can log the data and also help you, which logs the data. And in cases where if you want to use the M829, the mass flow controller, you can also control it from the software as well. So that's an interesting little thing. And these are also intrinsically safe. So the person wanted methane. They are intrinsically safe. If you want a corrosive material, though, you'll have to special order a corrosive material. They go up to about 20 SLPM on our online store, but if you need a higher flow rate, within reason, obviously, we can go higher than 20 SLPM. And that's measured in air. That's 20 SLPM air.
Yeah. Okay, next question is the first use of a pressure regulator. Is the pressure gauge was damaged. What would cause this? As the range of the gauge is greater than the output pressure capability of the regulator. They're saying it's not due to overpressure. Can you send a replacement gauge? So I want to talk a little bit about pressure. Well, we're going to talk about the regulator he has and about pressure gauges and damages and stuff. The customer had, this is our 3200 series regulator. It's a high flow regulator. Because it's a high flow regulator, it doesn't have an inlet filter. So these are more susceptible to,
that's the word,
to creep leakage. And what happened was, it was the delivery pressure gauge, the needle was bent. It was bent like this, which is kind of funny. And what had happened, what I think had happened, and we asked them to send it back for us to evaluate. What I think had happened was that the gauge got overpressurized. There's a little pin here at the bottom of the gauge where the needle can rest. And I think what happened was it got overpressurized on the downstream side, and then the needle wrapped around and wrapped around the pin. And that can be caused by a couple things. On a new installation is probably where you're going to see these kind of things. It could have been from someone was pressurizing downstream at a higher, for their leak testing or whatever, or they're setting something up, and they might have overpressurized downstream, and they could have, the gauge, I think they had a 100 psi gauge on their regulator. I'm sorry, 100 psi delivery, 200 psi gauge. So if they had downstream, they're whatever, pressurizing it up, and it got to 300 psi, you would have wrapped it around and
which could have been caused by creep.
Yeah, and also it could have been caused by creep if it was a first-time use. Yeah. And creep is if there's the regulator valve, the internal valve, will close at a certain pressure. So I mean, obviously you set the pressure for 50 psi. It should be at 50 psi, but with creep, there's a little particle on the valve, and it won't close all the way. So the downstream pressure will rise up above and can go to your supply pressure. So if you have like 500 psi coming in, and it's supposed to be 100 going out, well, it might creep up, and you can have slow creep, fast creep, and this is probably a fast creep to kind of wrap the needle around. So when you get pressure gauges, if they're broken, well, pressure gauges are indicating pressure. It indicates something. So if it's broken, there's probably a reason why it's broken. There's different ways that they can break, of course. We happen to have one that a customer sent back, a regulator that had been damaged. I don't know if you can see it on this, but the dial on the gauge got kind of, face of the gauge got kind of bent up, and that was probably due to, it probably got dropped. You know, we've seen that. Someone has a regulator, it gets dropped. That happens, and it will damage the gauge.
Bang it up.
So if you some kind of damage like that, if it looks like it was dropped, well, that's probably your problem. And as we inspect these on the way out, we would notice that. And you also, the needle wouldn't be able to move all the way around.
Yeah, because it
would get stuck on the
bent
top.
forward. Yeah.
Yeah, it wouldn't go around. It probably could go around, but it could get stuck up on there. And then what also can happen is, well, rarely on some gauges you could see the needle fall off, but you can see on this one, if you can wrap it around and hit it and bend it like a hook, then it's probably not going to fall off. But that's a possibility because it's a press fit on there. We've seen gauges that they won't read 0, they'll be reading up here. You know, there's no pressure in it, and the gauge will be reading up there. That could be that the pressure gauge, there's some gearing, internal gearing, and it might have jumped off the track.
Turn that around, show them.
Okay, yeah, this is that's why I did it. Yeah. I took one gauge apart that we had, and it's got a Bourdon tube, and then it's named after Eugene Bourdon.
Everybody knows that. Bill.
And then, okay, it's not angstrom.
Okay, it's not angstrom. Okay.
So in 1849, he patented the pressure gauge. He discovered something. He was working with steam engines for trains, and he saw that when he had a coiled tube, and when it was pressurized, it would try to straighten out. So he was also a clockmaker. That's why it's kind of, if you look at this, it kind of looks like clock gears.
It does.
And it's got a little coiled up spring in there too. So yeah, so 1849, it's pretty much the same design today.
Crazy. Something's not broke, you don't have to fix it.
Yeah, it seems to work. It's pretty amazing on there. So we talked about all that. Oh, also if you have regulator creep, you could possibly damage the diaphragm, because the diaphragm is typically good for your delivery pressure. So if you go over, if you have a shock pressure backwards, you might damage the diaphragm. The diaphragm, let's say for 200 psi regulator, if you put in 500 psi, there's a chance you're going to damage the diaphragm.
So bottom line, creep is bad. Don't be a creep.
Don't be a creep. Yeah. Okay.
Next question.
Put that away. All right, next question, we're going to talk about falling apart there, Corey?
Yeah, no. I got it.
Okay, someone has a regulator,
which is
the 3200 series inline,
and he returns.
Yeah, and it's different problem on here. They're having flow rates of typically 4 to 8 CFM, and they had occasionally incursions to 12 CFM, and they're using the model 3203, which is appropriate for this. And this can easily handle the flow rate that they want, but the problem is they looked at the flow curve and they saw that they were on kind of the left-hand side of the flow curve, so that the lower,
right there where marked red.
Yeah, so this is the flow curve.
As you can see, as the flow changes, it affects the pressure.
Yeah. And he said where the slope is pretty steep on that end, and it kind of levels off later on. And so they wanted to keep a stable outlet pressure, and this wasn't doing it for them because the small change of flow is kind of like a big drop.
Yeah, and so the main problem they had is they want a steady outlet pressure.
Yeah.
And so a regulator that could work for this is the LPHF regulator, which is a high flow regulator. And I printed out the flow curve for this one, and you know, flat. You just don't see that every day. I mean, that's pretty nice. This one is not made for UHP gases, though. So that's the one.
It's brass.
It's brass, yeah. So
and it's got a Teflon coated neoprene diaphragm.
Yeah. Teflon coated. Yeah, something like that.
Yeah. Reinforced.
So reinforced diaphragm. It's not stainless steel is the point.
Yeah.
And so, but this one would work for nice steady pressure no matter the flow. This is typically used for, this is our Laser Pro, which is typically used in welding applications, correct? Or no?
Yeah, well, laser applications.
Laser.
Yeah, laser welding applications.
Laser welding applications.
Yeah, so that has a very flow.
Yeah, very nice flow rate. It's a hog, it's a big one, but it works.
And here's our VOC question. So we had a customer who says they're looking for a replacement regulator to use the VOC TO 15 gas standards kept in lecture bottles. Would the 3570 series be compatible to use with a variety of gases found in these standards? So first we'll talk about it. If you know what the TO15 VOC stuff is, then yeah, you might as well just go to the end of the video. No, the TO15 TO is for toxic organics. 15 is an EPA method to analyze samples collected with canister sampling. So VOCs are volatile organic compounds. Now, most people probably have heard of that. If they talk about carpets or paint, we'll have volatile organic compounds, and you'll get kind of that smell right when you get paint.
Especially when you paint the carpets.
Yes, and you don't paint it. But that's just in carpets and paint. But in industrial applications, they're used in many facilities. Will have volatile organic compounds, and obviously you don't want to be breathing in toxic levels of that. That's why you analyze them. So, and these VOC mixes can be up to almost 100 components, and they're all typically ppm, and some are parts per billion range. So this is the 3570 series, and it's our mini reg. And with VOCs, you want to have low dead volume. You want to keep the volume down as small as possible for the gas flowing, because you got all those components and they're low ppms and they're low vapor pressure stuff typically. And you don't want to lose those components. You want to have them like fall off into the gauge or something like that. So you want to try to keep your volume as small as possible. So for mixes that are above 1 ppm, you can use our 3570. The internal volume of this, that's without the gauges and the fittings, is about 3 cc's. And then we've got probably the regulator that we suggest for if you have the mixture has less than 1 ppm components in there, is this little guy. You can find this in our online store. And this has a total volume of a little over 1 cc's. So this is really kind of tiny. And you got little gauges on there, and you got a 1/16 of an inch outlet. This is for CGA 180 on the inlet for a lecture bottle. We can adjust it to other CGAs if you need that. So this is kind of like the main deal to use for that. We also offer, this is kind of double wrap for freshness. This is a semiconductor grade regulator that's electro-polished. So you don't have as small of a dead volume, but it's got electro-polished surfaces, so that it's not as porous as just regular stainless steel. So less chance for components to hide. It's all welded. We weld on the CGA fitting on the inlet. Well, the gauges are VCR, you can't weld those on. and an outlet valve is welded on there too. And it's got a purge port too to set up there. So that's another possibility for
So
VOC.
the lesson here is that not everything organic is good for you.
Right.
There you go.
Some are toxic stuff.
Some organic things are not.
So our show went a little longer today, but I thought we had some really good topics.
Yes.
So thanks for tuning in.
And thanks for staying the whole time.
Yeah, and don't forget to, if you subscribe to our YouTube channel, then you'll get notified of these videos, and you also get, of these live streams, you also get notified when we post new videos.
Yep.
So that's all we got for this week. Thank you for joining us, and see you again next week.
Set your VCRs.